Hello, my name is Sharan Kumar and I'm from RY40 and my metric number is 191382078. So today I'm going to give an explanation on Lab 1 operational amplifier, inverting and non-inverting amplifier, that is for the subject electronic analog circuit. So as for the objective, it is to demonstrate an inverting operational amplifier circuit and also to demonstrate a non-inverting operational amplifier circuit. Next, to investigate the operational amplifier voltage follower. So as you can see, this is the introduction for the op-amp. You can see the formula and all the stuffs. So this is the info about ideal op-amp amplifier and also inverting non-inverting amplifier. So this is the components that we used for the result. It is 33 kilo ohm, 10 kilo ohm, 4.7 kilo ohm and also 1 kilo ohm resistors. As for the procedure of inverting amplifier, we should investigate an op-amp used as an inverting amplifier. Connect the circuit in figure 4.1. The small numbers in the diagram correspond to the integrated circuit chips pin numbers. So this is the diagram here, and also there are some other procedures, that is connect the RF value 4.7 kilo ohm with 1 kilo ohm resistors. So next it is about non-inverting amplifier. The same as just now, it is to investigate the operational amplifier used as a non-inverting amplifier. Connect the following circuit as figure 4.2 and repeat all the procedures in step 4.11 to 4.14. Okay, for the inverting amplifier, the input signal is connected to the input polarity of the op-amp. So the input is here and the output is located here. So when we run the simulation, we can get that the input signal is the green color and the output is the blue color. So to track it, I'm going to show here so we can see that the input is written in the below here, which is negative 1.983 volt for the input since the input is 1 volt for Vp volt peak, so it is total of 2 volt peak to peak and 1 kilohertz of frequency. So for the frequency here, the output that we get, that we can get that C1, we can get that the output is probably around negative 9.3487 for the 4.7 kilo ohm of RF. Okay, from the theoretical calculation, we can get that the gain is formula is negative RF over R1, that is 4.7k over 1k, and we can get negative 4.7. So as for V out, taken the gain times fit the input value, so we can get that negative 9.4 voltage. So from the experiment, we get the almost similar result. So next we proceed with the change the RF value. So now we need to change the value to 10k, then we start the simulation again. So we can see that the output value has increased or changed. So from now we can see that the output has become negative 19. So we supported with the calculation. The theoretical calculation is expected to get negative 20 volts. And as a parameter we can get negative 19.934. So this is the wave. So let's try again with different RF value. So we can get increase the value to 33 kilo ohm. Alright, so now we can already increase the value. So we expect it to become much bigger than the previous result. So the output now we can get is negative 26.0109, around that value. But from the calculation, we got the gain is negative 33. The VR is negative 66, which is not the same to the experimental result. This is because the waveform has been clipped. The reason why it's because the input is time with the gain of OPM is greater than the DC supply, which is here. So this is DC supply 15 volt positive and feed involved negative is determined whether how much the gain can be. So this is the non-inverting amplifier with 4.7 kilo ohm. So we start the simulation. So the output graph waveform will result that we can see here, that the output is in the phase with the input, the output and the input. So let's check the output result, which is here. So we get negative 11.342. So from the calculation for the non-inverting is the gain is equals to the 1 plus RF over 1 R1. So from the calculation we get 5.7 of the gain. For V out is gain times input voltage, so 5.7 times 2 is 11.4 volt. So from the calculation and the experimental result we get an almost similar result output voltage. So now we continue to DIV. We try to change the RF value. We change it to 10 and we simulate it. So the output voltage is increased to let me check, okay, to 21.864. Okay, it's shown here. It says the gain, the calculation, theoretical calculation. If the gain is 11, the VR is 22. So the waveform we get from the experiment is 21.864. So this is the value that I get from the experiment. So it's almost similar to 22. So we can accept this. So next we change the RF is equal to 33. So we change it to 33 kilo ohm. Right. Now we can, when we already increase, we can see there's a change in waveform. So the output is 26.010. So the reason why I click this is similar with the inverting amplifier, since it's already exceed the input DC supply. So what does it mean for this question? Does not inverting mean if a sine wave is connected to an operational amplifier, which means the output gain of the amplifier becomes positive. So the output signal is in phase with the input. Now for this discussion and the calculation, so based on the result that I have obtained for the inverting OPM, the result for 4.7K and 10K resistance It's almost identical to the theoretical calculation, but the 33K resistance is different due to the exit of the DC supply of the OPM, which result it being clicked. So for the 33K resistance shown in the calculation is the ideal of OPM. Another thing to note that the output waveform is inverted 180 degrees from the input due to the signal, the input signal connection. So for the non-inverting of OPM, it's almost similar to 4.7 and 10 kilo ohm, and it's similar to the theoretical calculation. Also, the 33 kilo ohm resistance also results in the waveform. So the output waveform for the non-inverting OPM is in the phase with the input waveform. So finally, at the end of the experiment, I have learned to demonstrate the inverting and non-inverting operation, the amplifier circuit using the multisim online software, and I also able to calculate the OPM voltage follower, which also mean uh, voltage gain, which shown in this experiment. Finally, I able to understand this the subject of operational amplifier, and that's all for today. Thank you.